Open the co-registered PET and MRI in the MRI cron program. Double check the registration here as well. The PET scan's draw menu to open VOI. Change the file type to Nifty or Analyze Header to allow you to use an image volume as a volume of interest. Then select the mask file you made in BrainSuite when the MRI was stripped. Use the draw menu to mask the image with the volume of interest and preserve the regions with the volume of interest. Close the VOI mask and save the masked PET scan with a descriptive name. The stripped MRI, the PET scan now shows only the cerebral portions of the volume. This is useful when you superimpose the two images. Merge the masked PET scan with the side-by-side MRI and move slowly through one axis to look for a region that is more hypometabolic. It can be very helpful to use a different color map like French to accentuate subtle differences. Drag with the right mouse button to turn everything else white but this region, and make certain no other region is more hypometabolic. Now select the 3D volume of interest tool. Adjust the first two parameters in this dialog until the volume of interest is highlighted. It may be helpful to select Zero Intensity Constrains the Edge. When you're satisfied, click Apply to create the volume of interest. You can use the Draw menu to save the volume of interest with a descriptive name. You can use the Overlay menu to see the volume of interest on the MRI, or the Draw menu to mask the MRI with the PET volume of interest. Open the co-registered PET scan in Image J. You can adjust the image intensity in the Image menu. The Edit menu to select all of the slices of the image. Use the Edit menu to invert the image. You want to invert all of the slices of the image. The inverted PET scan as an Analyze 7.5 file using a descriptive name. Compare the original PET to intensity inverted PET scan. In this case, that the image is flipped on the y-axis. It's still co-registered, but the orientation has changed. Open the T1 image in Amide as an anatomical reference. Always ignore the duration warning. Click on the T1 to make. Right-click on the T1 to adjust its properties. Change the color map to the first choice in the drop-down menu. Choose Import File, not Open Study to bring in your PET scan and inverted PET scan. Here you can see how the PET scan orientation is changed relative to the T1 reference image. Click on the PET scan to adjust its properties. Rotate tab to invert the axis, which restores the original orientation. Deselect the T1 image since you don't want to merge it with the PET scan. Use the File menu to export dataset. Select all visible datasets, analyze, and inclusive, then execute the save. Overwrite the old masked PET scan file. Follow the same steps for the inverted PET scan. Amide and verify the orientations of the T1, PET, and inverted PET scan. Windows FSL must be run inside a Linux virtual machine called the VMware Player. VMware Player. Virtual machine. Log in to Linux. The header and image files of the skull stripped T1 onto the Linux desktop. Start FSL and run fast segmentation. The header file of your skull stripped T1. Check partial volume maps, but be sure to check binary segmentation, one image per class. Then click Go. This is one process that actually takes quite a bit of time. You'll see the new images appear as compressed folders. Exit fast. The image we need is labeled T1 Seg1. This is the gray matter volume. Drag it into your working folder in Windows. You can close FSL, trash all of the files you added to Linux. Power off and close the VMware player. Check the results of your segmentation. Open the T1 image in Emericron and add the segmentation as an overlay.